Okay, welcome back everybody. For those of you who don't know me, my name is Ian MacArthur. I am one of the account managers here at SolidCAD out of Toronto. Today I have the privilege of introducing Richard Shaw, who is one of the principals at Strasman Architects. And his topic today is where CAD is still king, CAD versus Revit for design build pursuits. Really quickly, I want to give him as much time as possible, but if you do have questions, please feel free to enter them into the Q&A panel to your right of the screen, and we will address those during the Q&A session, which starts at 4:30. So that's all I've got to say. I'm going to hand it over to Richard. Give me a second here. Okay, you're all set.
So thanks so much, Ian, and thanks SolidCAD for providing the venue for this discussion and our presentation, and also for a perfect excuse to crack a cold one on a Thursday afternoon. So thank you for that. So after seeing Aziz's amazing full digital ecosystem, you got to be wondering what sort of flat earther presents CAD as king at a design build. CAD is king at a Revit pub night. And so I thought I'd put this in context. When SolidCAD first approached us, invited us to speak on the state of transit architecture, its relationship with BIM, one of the things that immediately came to our attention was why in our practice, a firm that has a clear majority of our projects delivered in Revit, maintains a BIM as our preferred working method, why are we still consciously using CAD for the initial phases of our design build projects, especially when we know that those projects will ultimately be delivered in BIM? So surely, and again, we're asking ourselves, whatever CAD can do, Revit must be able to do it better. But what we have found is that in dealing with the specific nature of competitive pursuit phase, the design build pursuit phase, the benefits of speed and economy often outweigh the benefits of the long-term benefits that Revit and the BIM process actually yield. So I'll get into that in more detail. And however, I'd also like to clarify, although we are in that mode of delivery currently, and it does sort of play into our current working method, as an office that has engaged Revit and that does engage BIM, we really feel that there is a way forward for Revit to compete at this stage so that we can bring the benefits of Revit that yield, again, efficiencies and economies and value over the course of a project. We can bring that into the pursuit stage and do so. And I think it's just a matter of how we approach our use of Revit. So really this presentation is less focused on the technical aspects of each platform, but rather on the implications of using each platform within the office, again, Revit versus CAD. So before I do that, a quick introduction into the firm. SAI is a firm located in Toronto, about 40 staff. We work across all sectors: academic, offices, interiors, civic, multi-unit residential, worship, healthcare. But we really have developed a specialty in transit and transit infrastructure. When I speak about transit and transit infrastructure, really, it's not just the public side of it, although we certainly engage in stations, and we'll be looking at a significant station a little bit later, but also in the back of house, the infrastructure projects, the maintenance facilities, the operational hubs, where you actually maintain, develop, build, assemble, and run a lot of the vehicles that actually enter out into the network. So it's less of a public interface, and these buildings really become complex engineering buildings with stringent operational requirements. So that's also, these are large buildings and significant pieces of civic infrastructure, and that's where we do a lot of our work as well. In terms of our engagement with BIM, we've been using BIM for the last 10 years, which I know there's a lot of firms out there that have been on board much longer, but we really have drunk the Kool-Aid and engaged in the Revit world and in BIM project delivery. And it is a significant portion of our project work. About 70 to 75% of all of our project work is delivered in Revit. So it really forms the culture of the office and our capabilities. So the about 20% is actually a MicroStation, and that's a unique delivery tool, and that's specific to TTC and some municipalities that require that. The remaining 5 or 10% is in CAD, and of that 5 to 10%, the majority of it is actually in the design build pursuits. So this is what we want to look at. Why is that last little component clinging on there in an office that's otherwise driven by, again, the benefits of using Revit? So the other side to it is design build. We like design build. It's part of the culture of the firm. We like partnering up with contractors, proponent teams. It's a very engaged and sort of, you know, shared risk philosophy that we like to engage in. You know, we like these types of projects because it does fit into, as I mentioned, the culture. So our approach, we're not heavy-handed designers, but we like to actually participate in the design aspects of that infrastructure, and it suits us very well. So some of the key projects that I want to highlight are some of the major infrastructure projects that were actually developed on a CAD on the pursuit phase, and then into Revit subsequent project delivery. Now, this is a TTC McNichol bus garage, which just recently hit substantial. It's a 300,000 square foot maintenance and storage facility, about $150 million design build with completed with Butcon Eastern. It's unique for a couple of reasons. One is it's for the TTC. One is it's one of the first design build projects that the TTC is actually engaged in for buildings. So it was a delivery method that was unique for them. And secondly, it was the first project that they were actually delivering in Revit. As I mentioned, MicroStation is the preferred method by which they actually deliver all of their TTC work, engineering and architecture. So this was a big step forward. The Kipling Mobility Hub is a large bus terminal integrated with the TTC subway station, and also the Go Transit station as well. You can see that on the image. It includes pedestrian bridges, tunnels, platforms, and it's about $100 million. Again, a design build, but with Elliston. And this project must be nearing, I think it's very clear to, or very close to substantial as well. And then the Metrolinx Rutherford Go Station, this is something that we're going to be talking about as our case study. $240 million design build finance with Elliston. This is part of the Metrolinx Regional Express Rail expansion on the Barrie Corridor. It's a significant project for that corridor, and again, it's starting to open up their two-way all-day service along that rail corridor connecting Toronto and Barrie at the other end. So a quick primer for anyone who's not actually familiar with design build approach. What does that actually entail? And I'm going to focus on design build in transit. So it's usually a contractor-led proponent team. The contractor generally assembles the individual consultant team members. The architect's not always or even usually the prime consultant. Again, a lot of that has to do with the fact that these are very heavy on the infrastructure, track work, civil, roadways, utilities. And so the architect's role into that, we are actually very often sometimes in the role of a sub-consultant. So again, we're not necessarily driving the process. And you can sort of see that on the org chart, right? We're sort of down there on the fringes. So the process starts with an RFQ, or request for qualification. So you have teams that are formed, usually 3 or 4 teams are shortlisted, and then an RFP is issued. That RFP contains a reference concept design, which is a set of drawings and specifications that will be used to define the project and represent the owner's requirements in essence. And also a critical one is the project specific outline specification. And I'll be mentioning the RCD and PSOS as we go. And these are almost the letter of the law. They supersede all aspects of the contract and determine compliance for the submission set. Usually the design is developed to about 30%. Typically this is defined in the RFP documents. And also it is very prescriptive on the specific drawings that are required. So we usually taking it up to the end of design development, generally. Some elements may be developed a little bit further, in support of the costing requirements. And in essence, this is like a call for tender. The deadlines are fixed and immutable. We are generally competing against 2 or 3 other teams during this process. And I think that's something that's key. It really distills all the decisions. Is it going to win? How is it actually sitting amongst the other teams and the proponents? Are we going to be the most effective design and the most efficient, cost-effective? So all of this relates and results in a process that is riddled with changes that come from the contractor and changes that come from the owner as well. And I'm certainly not implying that Infrastructure Ontario is an evil empire, but sometimes when you're in these processes, it does feel a little one-sided. As a designer, you're seeing a lot of changes that come out of this process. The rules are constantly shifting underfoot, and so we have to be very nimble in how we actually deliver the project. So it really comes into play, and especially on transit, where it's never just a sort of standalone site. It's always integrated into a much larger network. So there's broader decisions that are being made that will affect any given project site. So, and again, the slide captures a lot of how it feels, and some of it. Ultimately, the design process is riddled with change. So what does that mean for the contractor? He's really driven by 2 prime factors. Is it compliant? Is our design compliant? And what does it cost to build? These are the 2 that they're going to be on the hook for when they finish that pursuit phase, because they have to be as accurate as possible with that cost, and they have to know that it's compliant with the PSOS and the requirements of the RFP. Otherwise, they won't get through that. These are the 2 winning factors. So from the architect's chair, what does that actually mean in determining our decisions and how we actually engage Revit or AutoCAD? Because it's a competitive process, it's actually done at cost. And when I say at cost, it's usually a reduced staff rate. So you take your staff, you assign them to the project, their multiplier is determined and negotiated, and it's in essence at cost, with an understanding that you're deferring your standard rate until success. So all of that additional fee is at risk during the pursuit phase. And this is pretty standard. All the consultants during that will go through with this. And there's a small honorarium, but it's never enough to cover the project. The client isn't paying for this process. Ultimately, the contractor and the consultant teams are. So it's very much a pursuit, and so you have to manage it and approach it that way. The second aspect is that because it's the early stages, and because it's very fast and fluid, it requires senior staff to be involved. So from our chair, we've got senior staff working at cost, and we have to be extremely nimble and very mindful of time spent. So I'm going to go into the Rutherford site and the project as the example. This is the original site. Doesn't look like this anymore. There's a simple GO station in the middle there with a bus loop around it, 1 track, 1 platform, and a level crossing. And you can see it's obviously a commuter rail site because of the sea of parking related to it. So that's where we started. This is the proposal. This is where they're going with this project. So it's a 1,200 car parking structure, a new station facility, actually a new station built into it, an expanded rail corridor. You can see the 3 lines, rail platforms, pedestrian bridge accessing the rail platforms, a bus loop, a passenger drop-off, and also at the bottom, you can see this, a grade separation. So they've actually taken Rutherford Road underneath the rail and put in bridges. And what's cut off on this side is actually a pedestrian and cycling bridge as well. So there's actually 2 bridges that cross the grade separation. Just a quick close-up. So the parking structure is just a sense of scale and also a high visibility in the community. This was something that was really part of the PSOS. They wanted to ensure that this this enormous structure, had an aesthetic appeal, that it wasn't, it was visually interesting. It was a positive contributor to the community, has integrated art. You can see that in the glazing and the windows there. But that drove a lot of the decisions on the design for that. You can see this is the view here, the structure in the background with the overhead bridge and the platform, the rail platforms. The station plaza, again, an integration between the actual GO station itself and the open landscaped area. And what you can start to see is that there's a lot of little components all across the site. So, I mean, architecturally, there's a lot of small building pieces that need to be coordinated on the site, you know, with a mind to the actual detailing on each one of these. So this is actually another little bridge that approaches the rail platform. So how do we manage? So we got to deliver that project. We got to, is it CAD or Revit? So this chart, I'm sure you've seen this graph before. It's based on the McLaren curve, where you are looking at the tooling up and modeling time for Revit at the project onset. And this chart really was generated for an IPD project delivery, and that is, you know, very integrated into the Revit development. And in essence, it's intelligence and information at the onset to deliver value and coordination through the later stages of the project, where, you know, the impact of design changes, the costs related to these are, you know, grow exponentially. And so you can see the difference between a traditional design, we're going to draw it up in CAD versus the Revit. But, and this is how we engage most of our projects, and we do see the value in this. We have recognized that it does work, especially with the Revit platform, with modeling and BIM. But for the pursuit phase, what you're seeing at yellow is our resources at risk. So this is, again, all of our time and investment in there. And that hard yellow line, or that hard line at the end of DD where we transition, it really, everything after that is there's no guarantee. It is at risk. We may not see benefits from it. We may not even be involved in the project. We may finish the pursuit and close off, and that's it, move to the next one. So really we need to get the most value out of that initial phase, not assuming that we're going to lose, but being able to balance that with what we can do once we win it. So it's really about risk management at that side. So design documentation, you know, what tool is best for the job? Although there are many factors that come into play, we really found that there are three main drivers in this decision when it comes to transit design build. First and foremost is getting started. It's how fast can you get off the ground and get the team working. You know, a lot of that is a site and base plan. Everything that mechanical, electrical, structural, civil, everyone that needs and depends on this information at the onset, how fast can you get that going? Second is the assumption and the knowledge that there are going to be many major owner and contractor driven changes during the pursuit phase, that nothing will sit still. We have to test it. We have to try out options. We have to evolve the design, and really we have to explore what the project can be. Again, with the eye to, is it the best possible design? Is it compliant? And is it the most cost effective? And then lastly is just the level of deliverables. At the end of the pursuit phase, you know, we know we're handing in a 25% set of drawings, and, you know, how far do we have to go with that? It's not really our decision. It's predetermined for us. We certainly know we have to support the contractor and their pricing, but really it's about what will get through that. Is it compliant, and is it how much does it cost to build? So site plan at the onset, what we're looking at here is the actual reference concept design. This is the site plan that was issued to us, initially in PDF, and then it comes out in CAD in the subsequent weeks. The level of detail that you're looking at here really does reflect the resolution of the overall design. So we have to evaluate, you know, what's actually working on this, the organization, is this site compliant, is this layout compliant, and get started very quickly on moving this into what we think is the best possible design solution. You can't, in these processes, you can't ever take the RCD and assume that it is all, you know, the best solution. So, and even if it is the best solution and you work through everything and come back to it, you still have to go through that process. So on this site, it's a very large site. There's not an inordinate amount of architecture or building, but it is the architect's responsibility to assemble and distribute this site plan. So we're really responsible for the site layout. It's something that architects do well, and it's organizing all of that information together. And as you can imagine, it's a very large civil undertaking. The civil portion of this and the track work is significant. But again, it falls to us to pull it together and get that out as fast as possible. Then there's the other side to it, which is just analysis, right? Is using the tools and the documentation to test. We are ultimately designers. We want to see what it looks like. We want to see how it works. We want to understand it in in 3 dimensions. We want to be able to look at it and assess that. And so, but we need to do it very quickly and very flexibly. This model was generated in SketchUp. Again, very quick, unintelligent tool. It's very graphically driven, but allows us to make some quick decisions during the process. And the other aspect is that some of the other consultants are working in SketchUp as well. The landscape had their plan done, worked with our model and dropped it on there, and it forms a very effective communication tool. And that also starts to we use that and employ it for the presentations to the owner and presentations moving forward. And also analysis. So, throughout the process, as I mentioned, we have to test all the layouts, test it for compliance, test it for constructability, for cost efficiency, design innovation. We have to make sure that we are on board and have explored all the options to make this the best possible design, because we're in a competition here. So we need to be able to manipulate the layouts very quickly, distribute them to team members almost immediately, and use graphic communication tools on the presentation side. So it's got to happen fast. So this is the final submission. So this is actually what the site plan looked like when we closed off the pursuit. It was done in CAD. And the other thing that's worth mentioning is that because the contractor, who's focused on the pursuit submission at this point, he retains directly all of the subs. We don't retain the subs as we might if we were prime in a different project delivery, but the subs all work for the contractor. So they're free to use whatever medium they want. And I think the contractor won't be prescriptive about this, but you've got Civil 3D for the civil works and site works, Revit. For structural, they'll often engage that. I think Stevenson used Revit on this project. CAD for mechanical, electrical, landscape is also in CAD. And so what you need to find is a common language that you can export very quickly to all players and make sure that, that they have that base level of information, knowing that, again, it's going to change. We're not working from the same model in these regards. It's just using it as a communication tool with speed as the driver. So in case you forgot where you started, there's the RCD. This is what was issued, and this is where we went to. Issued, where we went. And although it may look like the same, I'll tell you, anyone that worked on it knows how different it really is. But at its heart, you see that the level of drawing and what the actual deliverable is from a document doesn't evolve that much. That really, it's all about the intelligence behind it as opposed to advancing the drawing and its information. So in general, changes. Revit is very effective, and we find that we use it all the time, of course, to incorporate changes, across all drawings, change the model. It's very good, but it's less about changes, and I think, in integration and coordination, more about exploring options quickly. So, for example, an example of an owner-driven change. This is a platform enclosure at the rail side. They had in the RCD. This is an image from the RCD. They wanted a full enclosure around both platforms. In essence, it's a 350-meter long structure and runs covering the full platform. This is what it looks like on the outside. This is what they had modeled up and issued as part of the RCD. This is what we actually drew. Tested up the design with cross sections and then plan it. Again, very quickly, we were able to determine life safety, passenger comfort, durability. Where does the rain go? Where does the snow go? How do we actually get air in there? Will diesel fumes accumulate? So we were able to look at that, test it with the engineers. Again, on plan, test the layout. Very simple, very quick drawing. Then this came out in the RCD, and I haven't modified this image at all. This is issued from the RCD with those exact markups. Platform enclosure, line through it. So late in the process, the addendum was issued and the closure was deleted. So we're mindful of how much time we would have invested in that, knowing how fluid that process is. So a contractor-driven change that I'm going to touch on is with the fins. Again, the RCD had horizontal fins. Very quickly, the contractor looked at it and said, that's very expensive because it needs a secondary vertical structure behind it. Is there anything you can do? So we took it away, proposed vertical fins, that we'd actually work with the fins and then spend the attention on the fasteners, providing a modular but adjustable fastener that would work with the precast system so that we could have a dynamic facade and not have to have a secondary structure, saving money and yet also achieving that expression that the client was looking for. So how do you communicate that? It's a fairly complex, it's an enormous building with thousands of unique elements on it. Again, in the pursuit phase, very quickly, using a hatch, we can identify how the design works, where those lines are, and then with a little Photoshop work, how the building's going to be experienced. Testing very quickly in 3D Studio Max, how the fins will look. And then actually in the design process, where we, after we had been awarded the project, we did model it up in Revit. And so at that point, we really understood how much time it was going to take to invest in that exercise and in developing that model, because we needed to have it in place for use as the generator for the shop drawings. And then on the right, you can see it actually installed. What does the final technical submission have to look like? This is the level of detail that we have to get to. It's communicating the maximum amount of info with the minimum light work. And that's not true for the whole project. That's just true for the design build phase. And it's that initial phase that's going through. And so drawings need to demonstrate compliance with the RFP. We have to take it forward as far as we can to do that. But again, coordination is such a strength of Revit, but in the design build, it's only really reviewed and required to a certain extent where we know that it won't impact the cost of the building as we move through coordination after award. So that's really the driver there as well. And often costing information can be supplemented. You can put in specs and so forth and other aspects to deal with that. So just because we have Revit, does it make sense to use it? We know that the office, we've invested all of this money, we have tooled up, we are engaged with the process, but how do we get through that very competitive phase? Is it the right tool for the job, or do we just feel compelled to use it because we have it and we like using it and we see the value and we're going to assume that we win every single design build that we enter into? So, it forces the question, if this is a successful methodology using CAD and then translating to Revit, why would we engage Revit? And to really answer that question, they have to look at the pitfall. Risk versus reward. The key on this one is if we do win the project, there will be a very aggressive schedule that the contractor has agreed to, again, to win the project. So very quickly, we'll have to move from a 30% CAD set to a 60% Revit set. And in a time frame that only had allowed for a development from 30 to 60. So you have to not only refine the project, but also make the transition between the two mediums. So we find that that's a real pitfall in this approach. And very often we end up trying to build the model in the time period between notification of prepared proponent versus the actual contract award. So it's still at risk, but allows us the time to do that. But again, we see that if we could come out of the pursuit with an element of geometry or an element of Revit and BIM that we could translate very quickly, it would actually suit us well. So how do we flatten the curve? Now, again, this is us messing with that curve, and is this wishful thinking? Can we actually minimize our involvement with Revit at the onset? Again, just targeted it to modeling and delivering only those elements that communicate and assist with the design decisions, facilitate a 30% submission, and yet will support and bring the value as you start to move through CD and into CA. With a design build, there really isn't a CA procurement and then a CD. It's just construction management. And as soon as the package is ready to go out, the subs are costing it all the way through. And in essence, you're designing in coordination with them and their shop drawings all the way through contract documents. So some of the things that we are looking at is establishing a BIM pursuit template within the office, trying to establish model parameters with the pursuit team at the onset, even though no one, we won't be engaging in Revit to start with. It's how do we establish that tool or that deliverable and those parameters within which we can actually model during the pursuit phase without having to redesign or rebuild the model when the coordinate system and everything else is established after award. So, and again, of course, at the bottom, hybrid, CAD site and Revit structures. This is something that we are engaging in the office and sort of continue to do. It's somewhat specific to transit, but it does allow us, again, to be able to have that responsibility and obligation to deliver the site independent from our own desire to forward the architectural components and the structure in a 3D coordinated model. So that's sort of where we're at. That's the forces at play. Certainly look forward to your feedback. And again, I want to thank Ian and SolidCAD for hosting us.
All right. Thank you very much, Richard. It was a really great presentation. Everybody, we're going to be hopping over to the Q&A session, the final session today, in a few minutes. We'll be live there in just a little bit, where you can join us. Thank you very much.